Reflection. Reflection, translation, and rotation. And those are all rigid motions. Okay, so there's that. Perimeter, I forgot how to do that. I gotta look that up. 14 times 3 is a perimeter. Oh, okay, so this is the example. Okay, so to find perimeter. Wait. Huh? I don't get that. Okay. Yeah, you know what? So here's what I'm gonna do. I'm not looking at that right now. I have to read that part. What's on the back? AA. Is this really important though? I'll box that up real quick. Trying to give myself as much room as possible. I might try to take this into the testing room with me. If anybody heard that, no, you didn't. I am a very loyal student. I would never do something like that. Okay. What was I gonna write? Okay. AA is two angles, matching two angles. Two angles. Okay. And SSS is equal sides and shape. That's all the information I have on that so far. So there's that. I can get rid of this paper now. Almost. 4. Yeah. This isn't important. Alright, what's this one? We got a little Halloween thing on the back. This isn't important. Front page. There we go. So similar triangle. $22 people? Holy cow. I mean, 22 pencils. 22 erasers. Crazy. I would have never imagined that. So the triangle, it goes same angles. Same angles, exact shape. Different sizes. Okay, there's that. My ponytail. I dropped the rubber band. No wonder. Okay. Congruent. All sides and angles match perfectly. All sides and angles match perfectly. I don't even know if I'll need this, but I'm writing it down anyway because I'm not trying to fail this thing and then have to retake it or like fail a Regents because of it. You know what I mean? I hate math. Why would I want to sit for another, what was it, 2-3 hours? I can't get back. No, will not. Will not. Okay. For perpendicular bisector equations, find slope and find the midpoint. Right, but how does that help me find the... 80, 20. Okay, so this is the midpoint. Yep. And then... But how was that the bisector? I don't understand. area. Oh yeah, I should probably write down those. I'll do the formulas later. Perimeter, simplest radical form. No, that doesn't make what? How the heck? He didn't even say anything about that. Maybe it's not important. Okay, let's look on this page. Mid segments. Okay, so the triangle. I'm gonna make like a mini one here. And right there is where the mid segments are. So each of these lines are mid segments. And then I'll put, I don't even know, bro. Top number will go on the bottom. Right number goes on the left. But, like, why did I write it like this? My God. Okay, so the bottom number goes on the top. So bottom, top, right to left, left to right. Okay. So whatever's here will go on this side. And whatever's on this side is going to go here. Okay, yeah, that's easy. Awesome. What? Kind of. Alright. Yeah. So we'll put these here, I guess. This will be X and X, Y and Y, and Z and Z. Yep, there we go. So Z is going to go on the top. Z, top, Y is going to go on the left, right? Yeah, that's the left. So, left. And X will be on the right. Awesome. There. That's written. I have that now. Top left, bottom left, top right, bottom right. Top right. Okay. We're gonna have a calculator, so it doesn't matter. Alright, so there's that. I already wrote that. Perimeter 26. I'm not doing all that. Backside. Nothing. I'm throwing it in the garbage. Okay. Next page. What's this? That was really hard for no reason. Okay. I'm gonna review this later. Front point slope formula. Y minus y1 equals mx minus x1. Boom. Okay, that's done. That's point slope. Midpoint. X1 plus x2 divided by 2. Y1 plus y2 divided by 2. And then I got to go over the nonagon, hexagon, decagon, dodecagon, pentagon, hex. Did I already say pentagon? I forgot. I gotta go through all those gons. Which I mean, I already know them. It's just like I gotta figure out how many rotations it can do to get back on its original side or whatever. I don't feel like it. I don't really feel like doing anything math related, honestly. Who would? If you like math out there, you're crazy. I want you to know that. So, hold on. Midpoint goes here. Pent. Hex. Octagon. Pentagon. Hexagon. Octagon. Notagon. I feel like I'm missing one. Isn't there supposed to be one like in the middle of that? Like 7 something? Pentagon. Hexagon. Octagon. Non. Deca. Dodeca. Is that it? Yeah, I think so. Pent. It's 5, 6, 8, 9, 10, 11. Oh, wait, no, that's 12. Stupid. Okay. Keep those right there. And perpendicular bisector. Oh, so I do need that. No! Why? I don't want that. So is a perpendicular bisector like the graphing thing? I think so. Okay, I'm gonna come back to that later. Center and midpoint. Center is where the medians intersect. Okay. I'll just keep that like a little tip. The centroid is where the medians intersect. If I'm being honest, I only went live because I need like somebody there. But I don't want it face to face because that's gross. I don't like being around people while I'm doing stuff. So I have you guys on here. Anyways, horizontal system goes that way. So horizontal goes like downish. Vertical goes more up and down. Keep those in a box. Awesome. It is not a rigid motion because it stretches out or something like that. Is this a rigid motion? No. Ultra blue Hawaiian? That sounds good. I mean, schoolwork, pencil, eraser, chair, desk, noises. Yeah. Rhombus has 4 equal sides. Diagonals are not congruent in a rhombus. I already knew that. In any parallelogram, the diagonals bisect each other. Trapezoid. I wrote down so many notes. Bro, that class bores me so much. I fall asleep writing notes. I'm not even joking. So, like, half my notes are, like, really sloppy. I'm cooked. I'm cooked. I can't even read it. Is she coming? No. I hear footsteps. Diagonals are not congruent in a rhombus. There we go. Okay. That's done. Alright. All right triangles are congruent. All right triangles are congruent. When you have two right triangles with a hypotenuse and leg, it is congruent. SSA is called HL. What was that? I forgot. Hypotenuse and leg. Oh, I just read it. I'm stupid. Oh my god. Okay. Two right triangles with hypotenuse and leg equals congruent. Awesome. There's that. That's written now. Boom. Okay. CPCTC. Corresponding parts of a congruent triangle. That's a lot of writing. A congruent triangle. Are congruent. Wait, what? Hold on, wait. Corresponding parts of a congruent triangle are congruent. Well, note if the triangle's congruent. What kind of math are they teaching us? I don't understand. Like, what? Obviously, it's congruent if I'm saying it's a congruent triangle. Why are you having me? You're having us go in loops for no reason. Obviously, if the triangle is congruent, the sides of the triangle are going to be. I feel like really stupid right now for writing that down. Like, okay, next paper. Midpoint, already know how to do midpoint and slope. Midpoint is right there, and the point slope formula. Okay, it's not important. Add x divided by 2, add y divided by 2. Slope and midpoint for perpendicular. Okay, so whatever I get from slope and midpoint is what I'm going to do for my perpendicular bisector. Okay. Already got that then in that case. What is that? Same shape and angle, similar. Same size and angles, congruent. There's a difference. Okay. Oh no. Alright, so same shape and angle makes that, what is that, similar? But if it is the same sides and angles, it's congruent. Okay. That's written. I don't think I need anything else from here. Alright. Next paper. This is slope, then midpoint, then something formula. Is this it? So I'm skipping that paper. I don't need it. Next paper. Let's see. Next biggest over next biggest when it comes to these. Okay, so I'll draw like a little model here for explanation because I know I'm not gonna remember that. So we'll do just like that. Boom. Okay. Biggest over next biggest. So 3.2 over 9.6, and then 4 over 12. So it's like the smallest for the vertical angles. Okay. Vertical angle. We'll put this as x here and y here, and x question mark, y question mark. So this is s over y equals x question mark over y question mark. That sounds about right. Okay, I can do that. Smallest, middle, biggest. Yeah, I'm not remembering all that. So we're just gonna keep that like that. I don't feel like writing down all those notes anyway. If I pass, I pass. If I don't, oh well, at least I tried. And I got backup notes, so it doesn't matter. Perpendicular bisector is literally just those two. So perp bisector. I'll get the equation for that in a little bit. Leave that spot open. Throw that away. This is garbage. I can throw that away. This is also garbage. I can throw that away. Find slope by midpoint. Simplest radical form. I'll figure out the primitive stuff later. There. Okay. So most of my notes are done and basically gone. Now what's this? Dilation, angles are the same shape. Dilation is not a rigid motion. Not rigid. ASS or SSA, not allowed. Wait. Coordinates. So I gotta box it in and stuff. Okay. Yeah, we're done. I'm done. 25 minutes for all those notes. This is going to go wonderfully tomorrow. I'm very excited. Time for me to go now. Got my 2 live streams.